Hi everybody, welcome to section 5.4. We're going to solve compound inequalities. And a compound inequality is when you've got two or more inequalities in a problem. Like x is less than -2 and, actually, no, let me fix that. Let me put an or there. Or x is greater than or equal to 5. That's a compound. It's got two parts, two or more. We'll stick with two. And it could contain either an and or an or. And or are our two possibilities. So this example that I gave you right here has got an or in it. An and might look like one of two ways. X is greater than 5 and x is less than 12. We could write that a different way. That could also look like this. Five is less than x, and x is less than 12. I usually read that backwards, and I start with the x, so I say x is greater than 5, and x is less than 12. But these are the two ways that we could have a compound inequality, either an and or an or, and that and could sometimes be stuck all in one. So let's start off with ands. So inequalities that contain an and, the first thing I need to tell you is that we're always going to use a double less than. And this is called the intersection. I am not going to ask you that. I can never even remember which one's intersection, but it's in there just so that you know. And it is true only if both parts are true. So both things have to be true. So we might have something like 0 is less than x, which is less than or equal to 5. So it's only true in between those numbers 0 and 5. And then we think, is there an open or closed circle at 0, open or closed circle at 5? And we'll graph these so you can see what I'm talking about. When we solve an intersection, you're going to separate the compound inequality. So I might have something like this. 5 is less than x plus 3, which is less than 9. So notice that in between the two inequalities, I have got an x plus 3. When I say separate it, I'm going to use the 5 is less than x plus 3. And then I'm going to use the x plus 3 is less than 9. So I use these inequalities, these less thans, as my breaking point. So I use the first two parts as one inequality. I use the second two parts as the other inequality. Once I've got them separated, I solve them each separately. So if I've got a 5 is less than x plus 3, I would subtract 3 from both sides. So I would say 2 is less than x. My other one, if I've got an x plus 3 is less than 9, looks like I should subtract 3, so I've got x is less than 6. So now I've got two solutions, and we can either graph or write those solutions in set notation. We'll talk about graphing in just a second, but we've got this example over here that we solved. If I'm going to write this in set notation, it says that x has to be greater than 2, and it says that x has to be less than 6. So if I go back to this set notation, I would say all values of x such that 2 is less than x, which is less than 6. So I took this, and I put that back in there. I took this, and I put that back in there. I just overlapped those x's, so I've got myself set notation. That says that this is true only in between 2 and 6. So numbers in between 2 and 6 would be 3, 4, and 5. That's the only time it's true, is when both of those things are true. So let's do an example. And there should be an and in between there, by the way. Let's graph the solution set of x is less than 3 and x is greater than or equal to negative 2. So notice how I gave you these little graph marks. I'm going to use this, and let's number these. Let's say if this is negative 3, negative 2, negative 1, 0, 1, 2, 3. Now I need to be consistent. If I want to make this double graph work for me, I need to be consistent and use the same numbering on all three of them. So this first one, I'm going to graph my x is greater than 3. Sorry, that's a less than. X is less than 3. So 3, I've got an open circle, and if it's less than, it's got to be going to the left. I'm going to graph on this second line, x is greater than or equal to negative 2. So that means I'm going to have a closed circle at negative 2. And if it's greater than, it's got to be going to the right, getting larger. The final one, and some of you will not need the top two lines, the final one is where I look to see the and. Both parts overlap. So where the and is, where they are both shaded, my final answer is going to be this last one. And if you don't need the first two, or you only need them for a couple problems till you figure this out, my final answer is going to be the and. I have got shaded from here to here. And then at those endpoints, I keep the same open or closed circle. So at negative 2, I'm going to have a closed circle. At positive 3, I'm going to have an open circle. And the only overlap, or the double shading part, is in between those two. So my final answer is that bottom number line that has a closed circle at negative 2, an open circle at 3, and everything shaded in between. That's how we graph an intersection or a and in our compound inequality. Let's do this one. Let's do number 3. So I've got this inequality. 5 is less than x minus 4, which is less than negative 2. It says to solve it, then graph it. So first things first, identify the part in between the two inequalities, the x minus 4. And I'm going to use these inequalities as my breaking apart. So I'm going to simplify and do a negative 5 is less than x minus 4. And then the second half of the problem, I'm going to do the x minus 4. Notice how that highlighted part is in both of those, is less than negative 2. Simple inequalities to solve. I'm going to add 4 and add 4. So negative 1 is less than x. Some people are going to start to do this to find that x minus 4 and just solve it and not have to break it apart. If you can do that, make sure I can understand your work. Here I will add 4, and I'd end up with an x is less than positive 2. No flipping of inequalities because we're only adding or subtracting. So I need to graph these two parts. So the top one, negative 1 is less than x. Of course, I'm going to switch that around, and I'm going to say that means x is greater than negative 1. So let's make this a negative. What did we start with last time? I can't remember. 3, 4. 0, 1, 2, 3. So for my first one, I've got negative 1 is less than x, or x is greater than negative 1. So I've got an open circle at negative 1. It's greater than, so it's going to the right. For my second one, I've got x is less than 2. So that means I've got an open circle at 2. And if it's less than, it's got to be going to the left. And for my final answer, again, you don't have to do the top two graphs unless you need them to kind of see where that overlapping is. But my final answer is the overlap. So I've got overlap negative 1 to positive 2. I'm going to keep the same open circles on both sides and shade in between. So my final graph, if I were to put this on a quiz or a test, my final answer for the graph portion of this would be an open circle at negative 1, an open circle at positive 2, and shaded in between. If I'm going to write this in set notation, I would say all values of x such that -1 is less than x, which is less than 2. I put these guys back together again and overlap those x's. Oops, didn't want to do that. Overlap these x's like this, and that's how I end up with that inequality back for my set notation. So let's talk about ORs. Inequalities with ORs are called the union. I don't really like using that term, but it would be something like x is less than -3 or x is greater than 0. So that's what those would look like. Compound inequality is true if one or more parts are true. So it doesn't have to be both parts are shaded. It could be either. If I gave you a peanut butter or jelly sandwich, you could have peanut butter or you could have jelly. It would be a true statement. If your mom's like, hey, I made you a peanut butter or jelly sandwich today. If she just gave you peanut butter, it would be a true story. The solution of the compound inequality is a solution of either part. So it doesn't matter what's shaded, or if it's double shaded, it only matters that it has shading on it when we graph them. So solving a union, we solve each part of the compound inequality separately, and then we're going to either graph it or write it in set notation. Set notation looks like this. We've got x, all values of x such that x is less than a or x is greater than b. And we just write the word or. We don't usually write an and for the intersection problems. We usually just put those together. So we've actually got the word or right in the middle of our set notation. So let's do an example. Let's do, let's skip this one. Let's go to number 5. Here we go. So solve -3h plus 4 is less than 19 or 7h minus 3 is greater than 18. Then graph the solution set. So we're going to do everything the same. We're going to solve this. Notice this is more than one step to solve. I'm going to start by -4. -4, so I've got a -3h is less than 15. So I'm going to divide both sides by -3. There should be bells and whistles going off in your head because when we divide by a negative, what happens to our inequality? Becomes a greater than. When I go to solve this one, I'm going to start by adding 3 to both sides. So I've got a 7h is greater than 21. Divide both sides by 7. Do I need to flip my inequality on this one? No, right? Because it's not a negative that I divided by. It was just a plain 7. So I'm going to sketch this graph of h is greater than -5. I'm going to sketch this graph of h is greater than 3. This one is a sneaky problem. I'm going to put this as my final answer. Usually we're going to have these guys, well, I'll show you in just a minute. All right, so if h is greater than 5, first -5. First of all, let me get my stuff on here. -5, -4. 1, 0, 1, 2, 3. Okay. So if h is greater than -5, open or close circle. And which way is our arrow going? If h is greater than 3, open or close circle. Now here's the crazy thing about these ors. You know how we said it could be peanut butter or jelly, it would still be true? So anywhere that it's shaded is going to be a okay answer for us. So where is this shaded anywhere? It's shaded from -5 on up past 3 and it keeps going. So my final answer, anywhere there's shading, would be an open circle at 5 and all the way up. Let's go back to number 4 just so that you can see this one was a weird one because they were both going in the same direction. And that's when you have to ask yourself, or means any shading is true. So this one, it happened to overlap, but it doesn't usually. So back up to this one real quick, because this is a short one. It says graph the solution set of x is greater than 3 or x is less than or equal to -2. So here's x is greater than 3. Here's going to be x is less than or equal to -2. And here's going to be my final answer. If you don't need both lines, you don't have to use the top two. So let's do a -3, -2. The worst part is making the number lines. So for the top line, if x is greater than 3, open or close circle. And which way should that be going? For x is less than or equal to 2, open or close circle. Closed, right? And that one is less than. So or means any shading is okay. Any shading. So where is it shaded? Anywhere on my graph. Or maybe where is it not shaded? There's no shading in between -2 and +3. So that means on my final answer line, I can have no shading between them. I keep the same dots. And I keep the same open on this side. So my answer will be 2 arrows going in opposite directions because it doesn't matter where it's shaded as long as it's shaded. So, lesson summary. Number 1, what does set notation look like for an intersection, and what does set notation look like for a union? So I just want you to go back and revisit that set notation. Which one's an or, which one's an and. I won't ask you to memorize those two things, but since you got your notes in front of you, you can definitely see that. And solve this. I should probably put and graph. Notice it's solve and graph, which means both things have to be true. If it said solve or graph, you could do either one and you still would have gotten it. Since these are both less than signs, that means this is an and problem. So this is like the first example that, or first two examples that we did. So if it's got less thans, it's going to be an and. That is it for section 5.4.